Hello everyone. In this video, I'm going to explain problem number 2.18, which is a chapter 2. The question statement is the rate of heat generation per unit volume in the uranium rod is given, and he's referring to this one here, 7 times 10 to the power 7 watts per meter cube. And what he's asking is the total rate of heat generation in each rod to be determined. That means there's one question, and the iron heat flux on the surface of the rod, the second question. And dimensions of the rod is given in this picture. What I have done is I took that information, basic information, and placed into this my worksheet here. And first, G dot, which is given, is the rate of heat generation per unit volume. And but the question is he wanted a total rate of heat generation, which is the symbol for that one is E dot generated, and that is in watts. That's what we wanted. What is the relationship that holds them together? The relationship is E dot heat generated equals capital E generated, that's total heat, divided by the volume. It is a very simple formula. So rewriting it in terms of what our question was, we wanted total heat generated equals E dot gen times volume. And plugging those values here, 7 times 10 to the power of 7 watts per meter cube times area, we need the volume of the rod, which is pi diameter square, pi d square by 4 times the length. Everything is in meters here, okay? So by simplifying it, you'll come up with an answer of 137 kilowatts. So that is the total heat generated. So that is question number 1. What is the second question? He wanted to know the heat flux on the surface of the surface. What is the heat flux? The formula for that is we needed a total heat generated first, which is already calculated, and the surface area of the rod. So surface area of the rod is pi times diameter times length, pi dl. So you plug those values, 137 kilowatts divided by pi times 0.05 meters times pi dl, which is 1 meter. So simplifying that, you will come up with the answer of 872.17 kilowatts per meter square. Pay attention to the flux, kilowatts per meter square, whereas this one was kilowatts. Okay, so that is basically the two questions. I hope I made it clear for you, and so this will have the answer. Well, thank you.